Alright, so in this video I'm going to discuss the cross product. Now when we talked about the dot product, it gave you a parallel answer where we had A times the portion of B that was in the same direction as A. When we deal with the cross product, it's going to give us a perpendicular answer. So I've sort of drawn over here, we have vector A, we have vector B, there's some angle apart from each other. And the cross product of A cross B is directly perpendicular to the plane of A and B. So the cross product is always going to give you a vector that is perpendicular to the two vectors that you're taking the cross product of. So in physics, we're going to find that there are two quantities that when we multiply them together, the result should be perpendicular. So instead of using regular multiplication, we need to use vector multiplication in order to get the answer to reflect what we see in the real world. I will want to make one side note here. When you do a dot product, A dot B is the same as B dot A. When you do the cross product, that's not the same thing. A cross B is equal to the negative of B cross A. So you'll get the right magnitude and you'll get technically the right direction, but it'll be exactly 180 degrees from where you actually want it to be. So if it's supposed to be Z, you'll end up with an answer of negative Z if you flip the order of the two vectors you're trying to take the cross product of. Alright, so notice here when you do the cross product of parallel components, so A of X times B of X, you get 0. Because this gives us perpendicular components rather than parallel components. So we're only going to get a response when we are taking the cross product of components that are 90 degrees from each other. Now there are two ways you can do the cross product, and it depends upon whether or not, of course, you have available this long formula I've written here. Where this formula A cross B, notice we have Y and we have Z and Y, so we're taking and multiplying together the components that are 90 degrees from each other, and that gives you the component that is 90 degrees to the two components that you're multiplying together. And you see that pattern repeated, where this is Z and X, but that gives you the Y component. And this is X and Y, but that gives you the Z component. So you're multiplying together the components that are perpendicular to each other, and that's going to give you the component of the answer that is 90 degrees to the two of them. Alright, so there is a second method of finding the cross product that doesn't involve memorizing this big long equation, because I don't always want to have to look up this equation every time I want to do a cross product. But it does require remembering a pattern, and it's a little bit difficult to explain in a video. So whenever you do this, you are covering up the column, so we have a matrix here. Essentially what we're doing is taking a determinant. So since we're doing the X component, we're going to cover up the X component because that it would end up being parallel rather than perpendicular. And we're going to do A of Y times B of Z, and then B of Y times A of Z. So notice that pattern matches here, where we're doing this, that would be my first cross, and then this would be my second cross. Then when we want to do the Y component here, we would cover up the Y column. Now this one is a little bit tricky because you have to do the pattern opposite of what you would do for X and Z. So we started up top and did A of Y first, but now we need to start at the bottom and do B of X times A of Z, and then A of X times B of Z. So you can see here once again that the first multiplication matches this, the second multiplication matches this, and then you would just subtract those two terms. And then finally, let me pick another color. Let's try green. We're going to do the Z hat direction, which means we're going to cross out the Z. And now we're going to start once again at the top. So we're going to do A of X times B of Y minus B of X times A of Y. And that'll give you your Z hat component. So it matches this here, where you're taking the first multiplication as this, the second multiplication is this, and then you're subtracting the two terms. So the determinant method is a way that you can more easily memorize what the cross product is rather than having to memorize this long formula. Because once again, it might be in an equation sheet, but on the other hand, sometimes you don't always want to have to look things up. And so notice when I'm creating this matrix, I'm essentially doing the x's in this column, the y's in this column, and the z's in this column. And lastly, I want to point out that the cross product does give you a vector answer. So whenever you're taking the determinant or you're using this long formula here, this is your x term, this is your y term, and this is your z term. If you want magnitude and direction from that, you have to use Pythagorean's theorem and inverse tangent. You cannot add these three terms together because you would be adding an x term to a y term to a z term. So this is also a little different than a dot product, where the answer was scalar. So when you did a of x times b of x, you can literally just add it to a of y times b of y. In this case, you cannot, because you are creating vector components whenever you're taking the cross product. So be careful of that. You cannot add these three terms together. You have to use Pythagorean's theorem and inverse tangent in order to find magnitude and direction.